Hello, if you've been following Python tutorials, you've probably seen just run pip install something, but what is pip? Where do packages come from? And why does this sometimes break? Today we are demystifying Python package management. You'll learn what pip is, how to use it, and how to avoid common mistakes that break your projects. Let's dive in. Imagine you have to fetch some URL on internet. Sure, you can learn all the levels of a C model, write your own encapsulation implementation, learn HTTP specification and implement it. Or you can use Python request library. Sounds good, but where will you get this library and packages? Simple. Python ecosystem has Python package index, PyPI, which is the official Python package repository. Open your browser and navigate to the pypi.org. Here you can search for the package you need. Just type request in the search bar and navigate to the package details page. Here you can find all the information you need, usage examples, authors, link to the documentation and the source code, as well as installation instructions. As you can see, we were instructed to use the pip command to install the package. But what is pip? Pip is the standard package installer for Python. Usually, you don't have to install pip manually, but it's always a good idea to check if it's installed and its version. If pip is not installed, you can simply install it by running ensure pip model. Okay, pip is working, so we can get back to the package installation. To install the package, you will use the install command. Simple, isn't it? That's it. You have installed the package. Now you can use list command to check the installed packages. As you can see, the request package of the specified version is installed. But there are some other packages that we have not installed. Where did they come from? Let's run the command. This command will show details of the installed package. Take a closer look at the requires section. Yes, the package can depend on other packages, and pip will resolve the dependency automatically. If you look at the details of the certificate package, for example, you will see that this package is required by the request packages. To remove the package, you can use uninstall command. Note that uninstalling a package will not remove its dependencies, since other packages can be dependent on it. Let's reinstall request package once again. And now let's try to remove one of the request's package dependencies. Pip will allow to remove it, but your request package will be broken. You can use command check to check if you have some broken dependencies. As you can see, pip is notifying you that you are missing request package dependency. You can fix it by reinstalling the request package or by installing a certificate package itself. But I would recommend reinstalling the request package itself, since it may be dependent on the specific version of the certificate package, and installing another version may leave your setup broken. Let's actually try it by installing an older version of the certificate package. pip is telling us that we use an outdated version of the certificate package. But you can update the package specifying upgrade flag to the install command. As you can see, certificate package is successfully upgraded. We have almost done with the packages. But imagine you are working on the project that requires several dependencies. For example, you need a request package to fetch data, numpy package to analyze data, and openpyXL to make XLS reports. Sure, you can install these packages on your machine. But what if you have to share your code with someone else? Yes, you can message another developer and tell them that he or she should install specific dependencies of specific version. But this solution is not very scalable, or I would say not scalable at all. Instead, you can prepare requirements.txt file with all the dependencies of project and their versions. Now you can share this file as part of the project and install all the required dependencies using the following command. You can also upgrade all the packages listed in the requirements file, adding upgrade flag to the install command. During this video, I mentioned package versions several times. But what is the version after all? Python is mainly used to versioning schemes, semantic versioning and calendar versioning. I'm going to talk about semantic versions here. So, let's check request function detail. As you can see, we've installed request version 2.32.5. Each number in the version have its meaning. 2 is the major version. Major version updates when you introduce public API changes and do not grant backward compatibility. 32 is the minor version. Minor version updates when you add functionality in backwards compatible manner. And 5 is the patch version. Patch version updates with the bug fixes and patches. But why all this information matters? Well, when you see new version of the package released, you almost always know is it safe to update. If patch version change, great, safe to update, just bug fixes. If minor version changed, usually it's safe to update, but I suggest spending some time reading release notes. And if major version changed, well, better start new project. But let's say we want to automatically update patches and minor versions of the library, but do not want to switch to the major versions. Let's get back to our requirements.txt file. Here we can specify exact version requirements we need. Let's update request library version requirement. So now we say that we want at least version 2.32.5, but not the third major release. And every time you run update, you will update request library to the latest version of the second major release. It's also worth to mention that you can, and should for the production environments, log the specific version of the package, like we did for the numpy and openpyXL in the requirements.txt. I hope that now you have a better understanding of how to use third-party packages in your projects. If you like this video, give it a like, subscribe to the channel, and see you next time. Ciao!